Hello everyone, and welcome to the Data Engineering Zoomcamp 2025 Homework Week 3 Solution video. So here I am in the course GitHub repo, and we have the homework file, and there is a load script included if you didn't want to manually download and upload those files. You could have also used an orchestrator, but in the instructions, we do state to stop at loading the data into the bucket. Don't load it into BigQuery. That's one to avoid some errors you might get with data types. And those are really hard to track down because a lot of students might be doing a lot of different things. And also because we're going to start by creating an external table. So you were instructed to just load the January 2024 through June 2024 data files, not the entire year, because that could take some time and it is a lot of data. Okay, so here I am in my project, the DE Zoomcamp Homework 3, and if I just go and look at my storage here and buckets, you can see I have my bucket actually named the same as my project. Don't let that throw you off. Yours will definitely be named differently, but here I have the Parquet files. Okay, let's switch back to BigQuery here. And I have these scripts saved just so I don't waste a lot of time having you watch me type these out. So if we look at the instructions, create an external table using the yellow taxi trip records. So if I go ahead and open this up, create or replace external table, and then my project name followed by the data set. In my case, I just called it HW for homework. And then whatever you want to call your external table, I'll make this a little bigger. I called mine Yellow Taxi External Table, just to make that clear. For options, they are Parquet files. And then it just needs the path to your bucket for the URIs. Because these are the only files I had in there, I could have just done star. If I had other files, I could have gotten by probably with yellow, and I think the wildcard works in the middle. If I had green and FHV, other files like that. So, going back here, create a regular materialized table in BigQuery using the yellow taxi trip records. Do not partition or cluster this table. This can be a little confusing because a regular table in BigQuery is just called a table. I sometimes call it a regular table or a materialized table. Hopefully I don't mix and match in this video, but just know those are the same things, meaning the data is in BigQuery itself. So to do that, we would just create or replace table without the external in front of it. And again, project name, data set, and I called it materialized table, again, just for clarity, and then select star from the external table. And I've already run that. If I scroll down here and expand my data set, you can see I have the external table and the materialized table. Okay, that takes care of the setup. So moving on to question 1. What is the count of records for the 2024 yellow taxi data? All right, you could have used the external table or the regular table. In my case, I used the regular table, and we just go ahead and run that. We get 2 million, let me make sure, sorry, 20,332,093 records. So if we go back to our options here, it would be this option here, 20,332,093. Okay. Question 2 asks us to write a query to count the distinct number of pickup location IDs for the entire data set on both tables. What is the estimated amount of data that will be read when this query is executed on the external table and the table? All right. You could have made 2 queries here. I just put them in one. Syntax error. Will semicolons get rid of those? Okay. I guess I need to zoom in a little bit. To get the estimated on something like this, you can just highlight it here. So notice when I do the external table, we look and the estimated bytes are 0. Why is that? Because those Parquet files are in a bucket and not in BigQuery, it can't reasonably estimate how many bytes it will need to process. If we go ahead and highlight for the regular table, we get 155.12 meg. So if we switch back here, this would be the correct answer. Don't think the others are really close, so if your numbers were a little off, hopefully that was pretty easy to see. And the only other one for 0 for the external table also had 0 for the materialized table, so that one's out. Okay, question 3. Write a query to retrieve the pickup location ID from the table, not the external table, in BigQuery. Now write a query to retrieve the pickup location ID and drop-off location ID on the same table. Why are the estimated number of bytes different? Okay, let's pull up question 3 here. And if you're not familiar, dash dash, that's pretty standard in SQL to comment out. Again, it's not liking my zoom, so hopefully you're on a large screen. So just doing the pickup location ID is 155. And throwing in drop-off location ID brings us to 310. So I won't read through all of these, but the first one is the correct answer. BigQuery is a columnar database, and it only scans the specific columns requested in the query. Query 2 columns requires reading more data than querying 1 column, leading to higher estimated number of bytes processed. And that's something to really just kind of drive home, as opposed to regular relational databases like Postgres or SQL Server. BigQuery is columnar based. So that question was just kind of designed to reinforce that. Okay, question 4. How many records have a fair amount of 0? So let me go and get question 4 here. So I'm selecting all records where the fair amount equals 0. 8,333. So that one's really just a little bit of SQL thrown in there. Probably could have ordered these different to maybe throw you off, but these homeworks aren't made to be gotchas. So the correct answer for question 4 is 8,333. Okay, the fun stuff. Question 5. What is the best strategy to make an optimized table in BigQuery if your query always filters based on TPEP drop-off date time and orders the results by vendor ID, and create a new table with this strategy? Okay, so the keyword here is filter, and filter is slimming down our result set, and we are trying to read less data. And when you start thinking about reading less data, you want to start thinking partition. And then when it's ordered by, the order that the records are stored, you want to start thinking about clustering. And I just have the Google page for that pulled up. Hopefully that's big enough. And you can see how partitioning and clustering kind of works. We can use date on this, so especially with dates, I should say. So rather than reading through the whole big lump of data, it's chopping that up into sections, and then when it sees that in your where clause, it's going to say, oh, I don't have to read all your data, I just need to read these pieces. And then if you see here, this is clustered by country, so you see the ordering is then by country. And if we bring that back to our question, it would be partitioned by the drop-off date time, and then we would want to cluster by the vendor ID. So let's see if I can find the right answer. So yes, partition by the drop-off date time and cluster by the vendor ID. To implement that, we would just create a replace table. You could just create table, but in case you're running this more than once, partition by, we need to convert that to date for the drop-off date time. Cluster by vendor ID, and I'm just reading from the regular table, and we run that, and that's how we get our third table. And I just called it optimized table. You could have called it partitioned and clustered table, something like that. But again, with table names, you probably just want to do what makes sense to you so you know what they are. Okay. So question 6. Write a query to retrieve the distinct vendor IDs between drop-off date time 3/1/2024. I should probably say this the long way. So March 1st, 2024 and March 15th, 2024. Use the materialized table you created earlier in your from clause and note the estimated bytes. Now change the table in the from clause to the partition table you created for question 5 and note the estimated bytes processed. What are these values? Okay. So, same thing again here. I just put them in one query window, that's fine. So here we have our regular materialized or just table, however you want to call it. I believe you could have used between here. You just would have needed to move this date to the end of February and this one to the 16th because that's not inclusive. But if we highlight that, there we go. So on the regular table, it's going to be 310.24 megs. And if we go ahead and do that on the partitioned and clustered table, it's 26.84 megs. So again, you get a lot of saving in processing. And of course, at scale, that would just multiply and cost savings as well by having a good partitioning clustering strategy. So if we switch back here, the correct answer would be 310 meg for the non-partition table and 26.84 for the partition table. Again, if your numbers were slightly off, hopefully they were close enough you could reasonably figure out what the answer was. Okay, question 7. Where is the data stored in the external table you created? So I'm just going to switch back real quick to the external table creation. And if we look, the big hint is here, pointing at our bucket. But going through these, BigQuery, well, no, that would be more the regular materialized table, whatever you want to call it. That puts the data in BigQuery itself. Container registry, no, that has to do with Docker, so just no. A GCP bucket is the correct answer because we're retrieving the data from those Parquet files in our GCP bucket. And Bigtable has to do with NoSQL. It's not touched on in this course, so again, just no. Okay, question 8. It is best practice in BigQuery to always cluster your data. Well, if you've taken exams anytime in your life, you probably know if something says always, it's probably false. But if you review the videos, Ankush touches on that. These days you could have been lazy, or I guess efficient, we'll call it efficient, and asked ChatGPT. But there is some overhead associated with clustering. And if you have very small amount of data, I forget what it is, a few gigs, but that overhead of doing that outweighs the benefits, so false. It is not best practice to always cluster your data. And there's a lot of other situations where you just wouldn't want to do that. It wouldn't make sense, but I won't go into that. And no points, just a bonus question. Write a select count query from the materialized table. How many bytes does it estimate will be read, and why? Oh, and I didn't write that, so I guess you will see me write a query. So we're just going to select count from and that estimates it will process 0 bytes. Why is that? Because the number of records is in the metadata in the table, so it doesn't need to go through, read those and process them. So that was just a little bit of a thinker, maybe get you doing some research and digging deeper on your own. But that was it for week 3. Hopefully you enjoyed this week, had fun doing the homework, or found it useful. Don't think there were really too many gotchas, so hopefully everyone made it through okay. But congratulations for finishing this week, and good luck with the rest of the course.